So, assuming you are not living in the moon or some weird basement for the last 6 months with no outside connections, you have already heard about AI. Of course, ChatGPT, Bing and Midjourney are the bigger names, but there are a lot more initiatives ongoing right now. And it is more than time for you to understand the basics of AI. Don't be an outsider, because this movement, it will not stop. So just sit down and in the next 5 minutes you will learn a lot about AI, but not with me. I'm calling Dr. Knowledge. He's a little bit shy, don't like to appear on camera, but it's insane. He knows everything. He's an AI expert. So let's call him. Dr. Knowledge. Hey Dr. Knowledge. We need your AI lesson now on the basics.
Of course, I love teaching. AI refers to the ability of machines to perform tasks that would typically require human intelligence to complete. In the world of AI, you will see these 5 concepts a lot of times, so let's start by defining them. 1. Machine learning. This is a subset of AI that involves teaching machines to recognize patterns in data and make predictions based on that data. We make use of the huge computational capacity of machines to start detecting patterns that lead to a correct decision or conclusion. 2. Neural networks. These are the foundation of AI, algorithms that make machine learning possible. They are inspired by the structure of the human brain. Neural networks are composed of interconnected nodes or neurons that process and transmit information. They are often used for tasks such as image recognition, natural language processing, and speech recognition. 3. Deep learning. This is a type of machine learning that uses neural networks with many layers. Deep learning algorithms, or neural networks on steroids, can learn to recognize highly complex patterns in data. 4. Natural language processing, NLP. This is a branch of AI that focuses on teaching machines to understand and generate human language. 5. Reinforcement learning. This is a type of machine learning where an algorithm learns to make decisions by trial and error. The algorithm receives feedback in the form of rewards or penalties for each decision it makes and adjusts its behavior accordingly.
Whoa, I really feel this is too much. So the last one is quite easy. It's like training a dog, right? If it sits, you give it a biscuit. If not, well, you say bad dog. Also, it looks like neural networks are the core here, so can you talk a little bit more about that?
Sure, that will be interesting, because neural networks is nothing more than engineers trying to use computers to mimic the human brain. Easy, right? The human brain is an incredibly complex organ that controls our thoughts, emotions, and behaviors. It is made up of billions of nerve cells, called neurons, that communicate with each other through electrical and chemical signals, synapses. These electrical signals can follow millions of different paths and trigger different neuron sequences. But the brain is also capable of modifying the strength of connections between neurons, a process known as plasticity. This is exactly what engineers start doing with computers. They created systems that are composed of interconnected nodes, or neurons. These nodes process and transmit information between each other. This computed neural networks learn by adjusting the strength of connections between neurons, a process known as training. Let's say you want to train a neural network to play paper, scissors, rock game. The first step would be to recognize pictures of hands. You would start by feeding the network a large dataset of images labeled as paper, scissors, or rock. Let's assume the simplest neural network with an input layer, middle layer, and an output layer where we will only have 3 possible outcomes. Now, the image pixels will be the input. For simplicity, let's assume there are only 4 pixels in the image. Each pixel value will form the input layer. Let's focus on this node. Remember that every node or neuron will be connected with all the nodes of the next layer. Initially, the neural network would make random predictions. Connections will have the same weight. Depending on the value of our node, it will trigger differently than next layer nodes. In each layer, we could program a different check or analysis, but the flow keeps going between layers until an output is achieved. Every time an error happens, the network would adjust the strength of the connections between its neurons, aka weights, trying to minimize the error. This is done using a technique called backpropagation, the process of feeding the input data into the network, calculating the error, and adjusting the weights is repeated many times over, with the hope that the network will gradually improve its accuracy in recognizing paper, scissors, and rock images.
Thank you, Dr. Knowledge, for these 5 minutes. What wonderful time to learn something new. And I know that you try to focus on the basics because neural networks can be really complex with multiple hidden layers in the middle. So we all leave this video with one finding today. No, machines can't feel and can't think. They can learn, they can analyze a lot of data and try to find patterns that lead to conclusions. And the way we interact with machines changed drastically. Now we give them inputs and outputs and let them define the rules. And if you haven't already, please Google search ChatGPT and try it out. It is a mind-blowing experience. Well, depending on the time that you are watching this video, maybe there's no more Google search. And if you like to quickly learn things like this video, just subscribe. I see you in the next one. Bye bye!